burn up a certain amount of heat and they get rid of a certain amount of critical mass and then they collapse on themselves and expand, and they've got all this stuff all theorized. I wouldn't argue with them. Maybe it's all true. I don't know. I don't think they know either. However, they're going to say to go from a red star to a white star takes hundreds of billions of years, or billions of years. This textbook says, if you look in the lower left-hand corner, it may take 100 billion years, or 10 billion years, or just a few billion years. The average size star, like our sun, would be in the middle there. They're going to say it takes, in 10 billion years, it'll change to a white dwarf. And they've got it all figured out how the sun, when it burns up a certain amount of fuel, it no longer has enough gravity to hold it together. So it'll swell up, like a marshmallow does when you get it hot over a fire. When it swells up, then it collapses back on itself, boom, and turns into a little tiny white dwarf star. And then that explosion, all that process is where the nova and supernova comes in. The star explodes. And they say the sun is going to swell up as big as the Earth's orbit, and we're all going to be fried in about 10 billion years. Oh, you better get a life insurance policy now, you know. Anyway, I doubt that's going to happen. But the stars do change, and yet all of the ancient astronomers, if you go back and read the records, yes?
You don't doubt that it's going to happen. No,
it's not going to happen. Period. God's heaven and earth. Well, heaven and earth shall pass away, but my word shall not pass away. So maybe He will let that happen that way. Interesting verse when it says the sun is going to scorch men in the book of Revelation. They'll be scorched with a fervent heat. Some Bible scholars will say, see, that's the beginning of a supernova. The sun is swelling. Well, it could be, or it could be the atmospheric conditions are different, you know. Just changing the atmosphere would scorch everybody here. You don't have to make the sun larger. Go to Sahara Desert, you want to get scorched, you know. 130 degrees, that'll scorch you right now. This idea about red stars changing to white stars is probably true. But all of the ancient astronomers referred to Sirius, which is the brightest star in the sky. If you go out on a cloudless night, other than the planets, which appear even brighter because some of them are, you know, so much closer, the brightest star is the star Sirius. Now, it's not the closest star. It's the brightest star. Everybody referred to Sirius as a red star. In you know, the ancient astronomers did. Today, it's a white dwarf star. This information comes from the book It's a Young World After All. It's a Young World by Paul Ackerman, which we have, I believe, right, Dan? It's out of print, isn't it? But we still have some left. It's back in print. Okay. Yeah, I've talked to Paul Ackerman on the phone several times. He said there's a couple things he'll change about the book next time that he's found out are not quite accurate, but 98% of it is really great. One atheist wrote me a very nasty letter about my mention of Sirius being a white star. And he said, don't you know Sirius is a binary star? There are two of them going around. I wrote back and said, yeah, and they're both white. So what's your point? It appears to be a binary star, two stars spinning around each other, and they're both white stars. So, just so you know that in case somebody questions you on that. Yes, it's binary, but they're both white. Okay. Let's move in now, instead of from the stars, though there's lots of evidence from space that the universe is not billions of years old. Let's move in just to our solar system. Two different words you need to be careful, Eric, not to confuse is the universe and the solar system. Solar system is just our 9 planets and the sun. The universe would be everything. All of the stars and planets, etc. Jupiter is a huge planet, but it's cooling off. Estimates are that it's losing its heat twice as fast as it gets it from the sun. Let's see. My very extravagant mother just sent us 90 parakeets, was the way to memorize the planets in order. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And if you want to memorize the distance to the planets, which I made my students do in Earth Science class, just to get a few of them, you can do it as an astronomical unit. It's a quick way to do it. Mercury is the closest one. It's 0.39. Venus is 0.7. Earth is 1. The distance from the Earth to the Sun, 93 million miles, is called an astronomical unit, AU. We'll get into that more of that later. Mars, I believe, is 1.5. Jupiter, which we're talking about here, if I recall, is 5 astronomical units. That means it's 5 times farther away from the sun than we are. If you're on Jupiter, the sun would look real small and would supply you with very little heat. Even Mars at 1.5 astronomical units is real chilly. 50% farther away than we are. These 4 planets are called the inner planets, and if you put it on a scale, You can do it with a ruler, 0.3, 0.7, 1, 1.5, 5. The next one, I believe, is 9. It goes clear out to 39, which is Pluto. 39 astronomical units away, which is why Pluto wasn't discovered until just recently. You got to have a really good telescope. And even then, they only noticed there might be another one because one of the inner planets was moving a little bit. In its orbit, it kind of bumped out of orbit. They said, oh, something must be pulling it. And that's how they detected Pluto, because another planet wasn't quite in the exact same spot where it's supposed to be based upon normal orbit. Who cares? Okay, you can get into that in Earth science class. Anyway, the point is, Jupiter's way out there, 5 times farther away than we are, and gets very little heat from the sun, and yet Jupiter is still hot. Now, how can you keep losing heat for billions of years? Wouldn't you pretty soon be cooled off? We cover in here evidence from space on page 11. If you want to read more references about this, you can document it. For instance, item number 9, Saturn's rings are unstable, they're breaking up. Jupiter and Saturn are cooling off rapidly. They're losing heat. You can see the reference here. Reference number 5, page 26. That would be from Edward Blick's book, Scientific Analysis of Genesis. Also, reference number 4, page 43. That would be from Ackerman's book, It's a Young World After All. Anyway, the way this works in the seminar notebook is so that you can look up the reference and the page number. It's kind of written right in here. It's a little different way to footnote, I know, but it's very fast and efficient. That's the way I use. It's not probably the standard way, which I very seldom have cared what the standard way is for anything. So, right, Dan? That's true. So the references here, that's how it works with your notebook. Jupiter has a little moon called Ganymede. It's not really that little. It's about the same size as the planet Mercury. So this Ganymede is one of the, I don't know how many there are now, maybe 20 moons around Jupiter. It's a lot. One of the moons, called Ganymede, is, as one of the Voyager's space probes went through it, the Jupiter probe, said there's a very strong magnetic field. And all they can figure is a magnetic field has to be produced by the inside core being hot. And to have something that small be that hot, when it's that far away from the sun, is surprising. A smaller body cools off faster than a larger body. The reason for that is, without going too far down this rabbit hole, your surface area increases in proportion to your volume as you decrease in size. Did we erase all that from the last time? No. Here. Okay, if you have a little cube that is 1 inch, 1 by 1 by 1, 1 inch cube, it has 1 cubic inch of volume. 1 cubic inch. The surface area, how many square inches of surface would it take to build that cube? 6. It has 6 square inches of surface area. Now watch this. So my ratio is 1 to 6, right? Now let's make our cube twice as big. 2 inches by 2 inches by 2 inches. What's the volume? 2 times 2 times 2 is 8. What's our surface area? 4 on each side. There are 6 sides. 24. What's our ratio? 1 to 3. You see what happened? This is a very important concept to understand because as you get smaller, if we made a cube that was 1/2 inch on each side, you would have 1/2 times 1/2, which is 1/4 of an inch on each side for the surface. 6 of those. You have 6/4 of an inch. That's 1 1/4 inches. Let's make this a 1/2. Oh, I'm sorry. This is for a 1 inch. This is for a 2 inch. Let's go to a 1/2 inch cube. I probably should put it above so it doesn't confuse people conceptually. Volume, surface area. If we go to a 1/2 inch cube, we now have a surface area of 1 1/4 who's got a calculator? 0.5 times 0.5 times 0.5.